Dear students, I welcome you to this class, and in this class we will learn how to solve ordinary differential equation by using Laplace transform. So, and that will be very beneficial in solving ordinary differential equation, and this is that will be the benefit of or the beauty of the Laplace transform. So let us start. So here is that solution of ordinary differential equation. We know that ordinary differential equation can be solved using a Laplace transform, and for those ordinary differential equation which has constant coefficients that can be solved by using Laplace transform. And in this method, first what we first convert that ordinary differential equation into some algebraic subsidiary algebraic equation, and which is the function of the Laplace transform of the given function, that is fx, or the given function is fx or y, or function y of x. Then if their Laplace transforms are fp or yp, then the given differential equation is first converted to subsidiary equation algebraic equations of fp or yp. After obtaining that, we apply inverse Laplace transform, and this inverse Laplace application of inverse Laplace transform will provide you the original function fx or yx. So the technique is that what is the technique? Technique is that the given ordinary differential equation is first converted into some subsidiary algebraic equation of the form of the Laplace transform of the given function or given variable. And after that, we should apply, and we will apply inverse Laplace transform, and then we will able to find out the variable fx or yx. So before doing that, we need to have the knowledge of some Laplace transform of some derivative of the given function fx or y of x, or we have to recall very often these relations that is here, that are summarized here. First one is here, a Laplace transform of f prime x, that is equal to p f p, where f p is the Laplace transform of the given function fx, that is, and then minus f0. L Laplace transform of f double prime x, that is equal to p square fp minus p f0, then f prime 0. In this way, for the nth order derivative of fx, L of fn prime x, that is equal to p to the power n fp minus p to the n minus 1 f0 minus p to the n minus 2 f prime 0. In this way, the power of p will be decreased, and final term will be here minus a to the power n minus 1 0. So this is the general formula, and this is for the function fx. And if you use the function as yx, then this fp will be replaced by y of p, and f prime x will be replaced by y prime x. So these relations will be very useful, and this relation will be used in solving the given ordinary differential equation. So let us go through some examples. This is the first example. The first example, we have to solve dy by dx plus 2y, that is equal to cos x. And in this case, a condition is given. The given condition is y of 0, that is yx is equal to 0, when x is equal to 0. Sorry, yx is equal to 1 when x is equal to 0. So I am rewriting this equation, that is here dy by dx plus 2y, that is equal to cos x. And this can be written in this way, y prime x plus 2y, that is equal to cos x. Now taking Laplace transform in both sides, what we will have, then Laplace transform of this y prime x plus 2y, that is equal to Laplace transform of cos x. Or this can be separated into two parts, that is Laplace transform of y prime x, then 2 of Laplace transform of yx, that is equal to, you know, that the Laplace transform of cos x is equal to p by p square plus a square. So in this case, a is equal to 1. So therefore, the Laplace transform of cos x is equal to p by p square plus 1. So then now, as you have the knowledge, or you know that that Laplace transform of y prime x, that is equal to p y p, then minus y of 0. So writing that the Laplace transform of y prime x would be p y prime, or p y p, that is the Laplace transform of this y is this, then y0 y of 0 plus from here to yp, that is the Laplace transform of this yx is yp, that is equal to p by p square plus 1. Now From here, see here, the condition, what was the condition? The given condition is y of 0, that is equal to 1. That means y is equal to 1 or x is equal to 0. So that using the value of this y0 here, so this is 1. This is 1. And from this term and this term, yp is constant. So p plus 2, that is equal to here p by p square plus 1, then plus 1 because y0 is equal to 1. So this is plus 1. So from here, that this is the condition is also written here. So yp is equal to p by, there should be p by p square plus 1 and then p plus 2. So p by p plus 2 into p square plus 1 and then plus 1 by this p plus 2. This is equation number 2. Now the first term of right hand side is broken into rational function, the fraction, as this term can be written in rational fraction, that can be written in this way: p by p plus 2 p square plus 1, that is equal to a by p plus 2 plus bp plus c by p square plus 2, where a, b and c are constants, so value are to be calculated or find out, are to be found out. So from here, so p by p plus 2 p square plus 1, that is equal to, just simplify is p plus 2 and p square plus 1 should be the denominator, and from here a into p square plus 1, then plus p plus 2 into pp plus c. So now comparing both sides of this equation, we can write that this a into p square plus 1 plus p plus 2 into bp plus c, that is equal to p. This is equation number 3. Now taking p is equal to 0 in this expression, or in this equation, p is equal to 0 we have. So from here a, and from here, since p is equal to 0, 2 into c, that is equal to 0, or c from here minus a by 2. And now taking p is equal to minus 2 in this equation. So if p is equal to minus 2, so this term will vanish. So only term is here, minus 2 square means 4 plus 1, 5a, that is 5a, that is equal to minus 2, or a is equal to minus 2 by 5. So c is equal to minus a by 2, and from here a is equal to, we obtained minus 2 by 5. So from here c can be calculated, since it is minus a by 2, just use the value of minus 2 by 5, and another 2 will be in the denominator, so 1 by 5 it will finally give you 1 by 5. And taking p is equal to minus 1 in this expression, if you take p is equal to minus 1, from this relation you have first from here 2a, and from here 1 into minus b, then plus c. So that means minus b plus c. So 2a minus b plus c, that is equal to minus 1. And from here b is equal to 1 plus 2a plus c, or just use the values of a and c that are here. 2a means 4 by 5 and c means 1 by 5. So calculating this 2 by 5. So all the values of a, b and c are calculated, and these are a is equal to minus 2 by 5, b is equal to 2 by 5, and c is equal to 1 by 5. Now we have to substitute these values in equation number 3, in equation number 2, in equation number 2, that means in this expression or in this equation, as well as that is here also, the left hand side is here also. First term, sorry, the first term of the second right hand side, this is also this. So here we have to substitute the values of a, b, c, and since according to this relation another term is here, 1 by p plus 2, that should be added with this. So after doing that we have, so that is here yp is equal to a, that is minus 2 by 5, 1 by p plus 2, then bp, p means 2 by 5 into p, c means 1 by 5. Okay, c means 1 by 5 by p square plus 1, and the next and the last term is 1 by p plus 2. And from here yp is equal to minus 2 by 5, 1 by p plus 2, then plus 1 by 5 is taken as constant term, common term from this. So this will give you 2p plus 1, then p square plus 1, and the last term is 1 by p plus 2. So that is equal to 1 by 5. You can write this 1 by 5, because it is 1 by p plus 2 minus 2 by 5 into p. It is here minus 2 by 5 into 1 by p plus 2, and it is 1 by p plus 2. This two just this two you need to just simplify this two, and that will give you 3 by 5, 1 by p plus 2. That is here. this term and this term will give you 3 by 5 1 by p plus 2, and this term is first this term can be written into two parts. One is 1 by 5 into 1 by p square plus 1, another one is 2 by 5 into p by p square plus 1. Okay, so this will give you this express these terms, and after that, if by using inverse Laplace transform for this expression, we have L inverse L, because you know that yp is the Laplace transform of yx. So this can be written as Laplace transform of yx, and then taking inverse Laplace transform, that is L inverse, that is equal to 1 by 5 L inverse 1 by p square plus 1, then 2 by 5 L inverse p by p square plus 1, then 3 by 5 L inverse 1 by p plus 2. So that will give you the result here. This is nothing but yx, that is equal to this is 1 by 5. We know that L inverse a by b square plus a square, that is equal to sin x. In this case, a is equal to 1. So L inverse 1 by p square plus 1 will give you sin x. After that, 2 by 5, then cos x, because you know that this is nothing but Laplace inverse transform of p by p square plus 1 is nothing but cos x. And this term is here, and this term will give you, because you know that L inverse 1 by p minus a is equal to e to the power ax. So that is here. In this case, you see here, a is actually, you can write from here that 3 by 5 e to the minus 2x. So this is the result. So the solution of the given differential equation is yx is equal to 1 by 5 sin x plus 2 by 5 cos x plus 3 by 5 e to the minus 2x. Now the next problem is here. Solve the equation d2y by dx square minus a square y, that is equal to 0, where a not is equal to 0 with the condition y of 0 is equal to 0 and y prime 0 is equal to 1. So rewriting the equation here, the given equation is d2y by dx square minus a square y, that is equal to 0. Perform here y double prime x minus a square y, that is equal to 0. This is equation number 1. Now taking the Laplace transform of this equation, both sides of this equation, that will provide you L of y double prime x minus a square L y prime yx, that is equal to 0. And you know that Laplace transform of 0, that will give you 0 result, because Laplace transform of c is equal to c by b. So in this case c is 0, so 0 by b, that means 0. So that is here. And now consider that the Laplace transform of y, that is Ly, that is equal to yp, and you know from the related the Laplace transform of derivatives that double prime y, that means p square yp, then py, then y prime 0, and that is this term will give you these three terms, and after that a square y p, that is equal to 0. So from here the boundary conditions are here, that is y of 0, that is equal to 0, that means this term will give you null result, and y prime 0, that is here, this will give you the result 1. So from here also yp, and this is also yp terms are there. So from here yp is taken as constant, so from here p square and from minus a square, and this term will give you null result, this term will give you result 1, so that is equal to 1. So yp is equal to 1 by p square minus a square, and that can be written as 1 by p plus a, p minus a. So that you can also write this as 1 by p minus a minus 1 by p plus a, just 1 by 2a into 1 by p minus a minus 1 by p plus a. Just simplify this, this will provide you with this result. Okay, you can check it. So taking inverse Laplace transform of this equation, both sides of equation number 2, we have L inverse yp, that is equal to 1 by 2a, then L inverse 1 by p minus a minus L inverse 1 by p plus a. So that is equal to L inverse, you know that yp is nothing but the Laplace transform of y function of x. So L inverse L yx, that is equal to 1 by 2a. And you know that this is the Laplace transform of e to the power ax, because you know that Laplace transform of e to the power ax is equal to 1 by p minus a. So this will provide you e to the power ax, and this will provide you e to the minus ax. So from there, so and this will give you yx. So yx is equal to 1 by 2a e to the power ax minus e to the minus ax. So this is the solution for yx, and we have calculated it by using Laplace transform. So next one is here, solve the differential equation d square plus a square into y, that is equal to sin bx, where a and b are constants, a not is equal to b and a not is equal to 0. So these are the conditions and we have to solve this expression, this equation, this ordinary differential equation. And now writing this equation once again here, d square plus a square y, that is sine bx, and this can be rewriting as like is, because in this case d operator is nothing but d dx. So d square means d2 by dx square, so that is d double prime, and this d2y will provide you d double y double prime x, then a square y, that is equal to sine bx. So now taking Laplace transform on both sides of this equation, we get L y double prime Laplace transform of y double prime x, that plus a square Laplace transform of yx, that is equal to Laplace transform of sine bx. And you know that Laplace transform of sine bx is nothing but b by p square plus b square. So here the right hand side will be b by p square plus b square, and from the left hand side you know that the Laplace transform of double derivative, the second order derivative of y is p square yp. Yp is the Laplace transform of y function of x, then py of 0, then minus y prime 0, plus a square, this a square, and Laplace transform yx will give you yp. Okay, that is equal to b by p square plus b square. And from here, this term, take this term and this term. So from these two terms, yp is constant. So common term. So from here, this there will be p square, and from here there will be a square. That is equal to this b by p square plus b square is here, and this p of y0 taken here, and this y prime 0 is taken also here. So that is equal to this. So from here y prime p, that is equal to p by from here p square plus a square, and this p square plus b square, then plus py of 0 by p square plus a square, then plus y prime 0 by p square plus a square. So this is the value. Now from here, therefore yp is equal to, you can write this term as b by b square minus a square, then 1 by p square plus a square minus 1 by p square plus b square. You just need to simplify this, and you will finally obtain this term from this term. You can calculate it, and it is your homework. So just check it. So this term can be written as b by b square minus a square, then 1 by p square plus a square minus 1 by p square plus b square, and this term is here remaining here, and this term is also here. Okay, by dividing these terms are also here. So these two terms are written here, and they are unaltered. So this is equation number 2. Now taking Laplace transform of this expression, we have L inverse, because you know this yp is equal to L should another L inverse yp. Okay, you know that is equal to nothing but yx, that is equal to 1 by b square minus a square. L inverse, you just write this term as because b is here, since b is here, this b is taken here, and here a is multiplied, so a should be here also in the denominator. So this is nothing but this b by p square plus a square, this term, the first term. So I am writing the first term as this b is here, and a is multiplied here, and another a is dividing by another a is here. So this b by this term is nothing but this term. Okay, and the second term is minus b by p square plus b square. Okay, plus y0 L inverse p by p square plus a square, then plus y prime 0 by a. I am writing just dividing here a by a, so here should a is multiplied here. Then L inverse a by p square plus a square, p square plus a square. So now just here writing this term 1 by b square minus a square. This b is here, and this a is also here, and you know that a by p square plus b a square, Laplace inverse transform of a by p square plus a square is nothing but sine ax. So this term will give you or provide you b sine ax by a, and the second term b by p square plus b square, that will result in the Laplace transform of b by p square plus b square will provide you sine bx. So that is here, and from here, see here, this is y0, and a Laplace inverse transform of p by p square plus a square is nothing but cos ax, and from here y prime 0 by a is here, and Laplace inverse transform of a by p square plus a square is nothing but sine ax. So the result is here y0 of cos x, just rewriting this equation, y0 cos ax, then y prime 0 by a, sin x is taken common term from this term and this term, so from these two terms sin x is there here, and from this term the rest part are y prime 0 by a, that is there, and from here b by a into b square minus a square, and the remaining term is here, that is that should be sin bx by b square minus a square, that with a negative sign, and that can be written as with a plus sign a square minus b square. Since it is b square minus a square, so it can be written as a square minus b square sin bx. So that can be written in the form y of 0 cos x is the first term is here, and this can be written as a sin x, where a is equal to these two terms, addition of these two terms, and b is equal to 1 by this, so b sin bx. So this is the solution. This is the solution of the given differential equation. Now another one is here, solve the following differential equation by Laplace transform method. The given equation is y double prime plus y 2y prime plus 2y, that is equal to 5 sin x, and you have given the boundary conditions as, or the initial conditions, or you have given the conditions as y of 0 that is equal to y prime 0 that is equal to 0. That means the value of the function yx as well as its first order derivative y prime of x that is equal to 0 for x is equal to 0. This is the condition. So now the given differential equation is here, y double prime plus 2y prime plus 2y that is equal to 5 sin x. Now taking the Laplace transform on both sides of this equation, that will result in l y double prime plus 2l y prime plus 2l y that is equal to 5l sin x. 5l sin l for the Laplace transform, and that will give you, this is the second order Laplace transform of the second order derivative of y, and that will give you p square yp minus py of 0 minus y prime 0, and this term will give you 2, then pyp minus y0, and this term will give you 2yp that is equal to 5, and you know the Laplace transform of sin ax is equal to a by p square plus a square. In our present case a is 1, so that will give you 1 by p square plus 1. And also you note from the conditions that y0 here is y0, so this term will give 0 result, and y prime 0 is also 0, so this term also provide you null result, and from here this term also provide you 0 result. So considering those conditions, we can write from here the first term is a p square yp, this term is 0, this term is 0, and from here 2pyp that is the first term, and the second term is also 0, and from here 2yp that is equal to 5 by p square plus 1. Okay, and from here taking yp as constant, so p square a common term, so p square plus 2p plus 2 yp that is equal to 5 by p square plus 1, or yp is equal to 5 by p square plus 2p plus 2, and this p square plus 1 is here, so that can also be written as 2p plus 3 by p square plus 2p plus 2 plus minus 2p plus 1 by p square plus 1. Just to simplify this, that will provide you with this result. Just simplify this. Okay, this can be written in this way, in these two parts, in two parts like this. You can check this. If you simplify these terms, that will give you the result that is written here. So now we are here to taking the Laplace inverse transform of this expression, this equation. So a Laplace inverse transform of yp that is equal to L inverse 2p plus 3 by p square plus 2p plus 2, then plus L inverse minus 2p plus 1 by p square plus 1. So you know that the Laplace inverse transform of the Laplace transform of the function y ax that will provide you yx that is equal to L inverse. You just rewrite this term as 2p plus 2 into 2p plus 1. That means 2p plus 2, then 1 should be added here also 1. So this can be written as 2 into p plus 1 by plus 1 by p plus 1. You can write this term as what? You can write this term p square plus 2p plus 1 plus 1. So p square plus 2p plus 1 that will give you p plus 1 whole square, then plus 1. Okay. And after that, this negative sign is here, this 2 is here, L inverse p by this p square plus 1, and plus L inverse this 1 is here by p square plus 1. So just separating these terms. So now from this term, so finally we get from this term we will get 2 L inverse p plus 1 by p square plus 1 plus 1 Then from another part is here L inverse 1 by P plus 1 whole square plus 1. Okay, this should be P plus 1 whole square. Okay, this should be P plus 1 whole square, P plus 1 whole square. Okay. So then after that minus 2 is here, and you know that this is nothing but L inverse P by P square plus 1 is nothing but cos x, and L inverse 1 by P square plus 1 is nothing but sin x. So this is from here minus 2 cos x, and this is from here sin x. After that, so yx is equal to from this term. You know that L inverse P by P square plus 1 is cos x. But if there, in this case, see here, P is replaced by P plus 1. P is replaced by, this should be P plus 1 whole square, this should be. So P is replaced by P plus 1. So in that case, another term e to the minus ex will be there. Because if in this case, if you know that Laplace transform of e to the power ax cos ax, that is equal to, in that case, or e to the power ax function fx, that is equal to, in that relation, you should replace this p by p minus a. In this case, see here, in this case, the positive sign, that means p plus p minus 1. So in this case, p is replaced by p plus 1. That means in this case, the term e to the minus x will be multiplied with the Laplace transform of cos x. So this will provide you 2 into e to the minus x cos x. Because the reason is here. L inverse p minus a by p minus a whole square plus b square, that is e to the ax cos bx. This is the reason. Okay, and this term will also give you e to the minus x sin x, because the reason is also here. L inverse b by p minus a whole square plus b square, that is equal to ax sin bx. So that is here also e to the minus x sin x, and these two terms are here. So after that yp, that is equal to, just simplify this, and finally we obtain 2 e to the minus x minus 1 cos x plus 2 to the minus x plus 1 sin x. Just simplify this. So this is the final solution of the given equation. So on differential equation. So we in this class have solved some ordinary differential equation, and in our next class we will solve some other problems. Okay, so this is the end of this class.